Alright, this time we're going to do a nucleophilic aromatic substitution. Alright, and so here we're going to start with our 1,chloro-2,4-dinitro-benzene. Alright, in order to do a nucleophilic aromatic substitution, you have to have a good leaving group, and that would be the chlorine in this case, which is a good leaving group, and you have to have electron withdrawing groups in ortho-para positions. NO2 is a strongly electron withdrawing group, and so this is an excellent reagent for nucleophilic aromatic substitution. Alright, and so now we're going to add the nucleophile, which is going to be aniline. And so aniline, the nitrogen electron pair, is going to attack the carbon with the leaving group, in this case the chlorine. And it's going to then add to this complex. So the mechanism shows that the electrons flow out to the electron withdrawing group in the, in this case, the para position is where I'm going to put it. And so our product here is that the aniline was added. All right, and so it has a plus charge. Chlorine is still there. And you have this complex. Now this complex has 5 resonance structures. I will show the 2 most stable resonance structures, where the negative charge is going to be on the oxygen in both of these important resonance structures. So you can show that the negative charge that was formed here by the reaction can go back into the ring and go out to the other nitro group and put the negative on that oxygen on the other nitro group in the ortho position. If there were nitro groups in the meta position, this resonance would not go out to that oxygen. And so the electron withdrawing groups must be in the ortho and para positions in order to give you the stable resonance structures. So there are 5 total resonance structures. Here are the 2 most important, the major contributors. The other 3 are less stable, minor contributors. They are there though, and you should write them, and they all have a negative charge on the carbon. And so for the other 3, you're going to have a negative charge on both ortho carbons and a negative charge on the para carbon. So you need to show the 5 resonance structures for that complex. Alright, and so now we're going to do a reaction, and again, we know a difference between a reaction and a resonance structure is if you form or break a single bond. Alright, and so the negative off the oxygen of the nitro group comes down, the double bond from the CN goes to reform the aromatic ring and kick out the chlorine. And so nucleophilic aromatic substitution is an addition. You add the nucleophile, and then elimination, you release the leaving group. And so the chlorine was released, and then that will pull off the hydrogen off of the positive nitrogen to give you your neutral product. And the name of this neutral product is N-phenyl 2,4-dinitro-aniline. And like the electrophilic aromatic substitution, I have started the reaction, and I should put my gloves back on, but I'm going to try to be careful and not touch it, although I might change my mind here. Alright, and so we have our compound that was being heated on the hot plate at a low temperature. Alright, we started with our 1,chloro-2,4-dinitro-benzene, and that is just a light yellow color, very similar to the product of the last reaction that we did, the electrophilic aromatic substitution. Then we added our aniline, which is a liquid in this bottle. And then we added our solvent, which is our ethanol. Alright, and so, and the directions are here. I put 7.5 mils of 95% ethanol, 0.5 grams of the 1,chloro-2,4-dinitro-benzene, and 0.5 mils of aniline. in a beaker. And I heated it on warm on the hot plate. I had it boiling, then I turned it down to warm, and it went for 15 minutes. And now all we have to do is collect the orange product. So it started as a light yellow, we have an orange product. We're going to collect that on suction filtration. And now in this case, we are getting one major product, and so we will need to get the melting point. All right, so I will do the suction filtration. Scoot over here. I got to make sure I don't get any orange near my skin. This product is a skin irritant, and if you get it on you, you'll have to probably take some Benadryl or something to make you stop being so irritated by the skin irritant. You'll be wanting to just an itchy feeling all over. Alright, so I'm just adding ethanol to get all of the solid out and also to wash off any impurities. Alright, so we should have a nice, clean product here. Alright, I'm going to let that dry for a while. We're going to get a mass and a melting point. Alright, so let's get a sample for determining the melting point. So I'm going to get some crystals off of here. Alright, so the capillary tube, you can see the solid. Not all of it went down. I don't need all of it to go down. I have some on the tip here, and if I keep tapping it I can get more to come down, but maybe I'll do that. Alright, and so I can take the melting point. Alright. Alright, so I'm starting the melting point. I'm going to start it at, well, I'm going to go up fast until it gets up to 150. So we're at 60, we are at 70, we are at 80, 90, 100, 110, I don't think that camera could see. I was going to try to put the camera into this, and I can barely see it with my eye. Try it. Let's see what this looks like. Alright, so we're watching that temperature. It's going up fast until it hits 150, and we're looking in the center, the one in the middle, looking at that crystal, and so we're going to see when that melts, and then the temperature when that melts. Right. So you got to have the right angle. Not sure if I'm getting the right angle. I can't see it. So we're at 140, as maybe you can see. 142 here. Trying to see if. So there is, alright, that's the best picture right there. Now, can I see it? Alright, so it's still a solid. I have to move the camera out of the way for me to see it. Alright. So we're at 145, as you see the temperature going up on the screen. And the crystals are still solid. They have not melted. And again, that's the orange in the center of your, there's three little pegs inside. Our product is the one that's in the center. There's nothing on either side. This is hard to shoot. Okay. Alright, we're at 150. Go. Okay. I didn't push the button to go higher. So I wanted it to stop at 150 and then go up from there. And so that's where we're at. So we're trying to see when the melting starts and what the temperature is. My arm is getting sore. All right, so you get the idea. We're looking at that. We're looking at that. I have to. We're getting closer to the actual. Well, I can see it, I guess. So my arm is getting sore. So we're at 153. Still a solid. Put this down. My arm is getting too sore. All right, I'll give you the play-by-play. It's kind of going up really slow. All right, and we're still doing the suction filtration. I should have went up further. Assumed that our product was pretty pure. All right, so we're only at 155 right now. All right, and it is starting to melt at 156. So 156 is the melting point. Now let's get the mass. Alright, so I'm going to be careful to not get any orange on me because it is a skin irritant. So a good amount of product. mass. .47 grams. 0.47 grams is the yield for that. All right, and that is the end for nucleophilic aromatic substitution.